Hello everyone. Now we are going to see how to derive the closed loop gain of non-inverting amplifier circuit using op-amp in practical case. As we seen in the previous video, we already derived the non-inverting amplifier closed loop gain for the ideal case op-amp. As we know that for the ideal case, the two input terminals of op-amp are same, so I can write the differential voltage between the two terminals of op-amp are same, so virtual ground concept is applicable. And also we have derived the output voltage V0 value for this circuit is Vi into 1 plus Rf by R1. Okay, so from this we can write the closed loop gain for the op-amp in ideal case is 1 plus Rf by R1. So this is the closed loop gain of a non-inverting amplifier circuit using op-amp in ideal case. Now what we have to derive? We have to derive the closed loop gain of non-inverting amplifier circuit using op-amp. For the same circuit we have to derive ACL value in the practical case. Now what do you mean by practical case? In practical case, the differential voltage between the two terminals is non-zero. So if you consider the op-amp as a practical case, here the differential voltage is not equal to 0. So from this I can say that the differential voltage can be expressed as difference between the voltage at the non-inverting terminal of op-amp to the voltage at the inverting terminal of op-amp. Now from this circuit, this V1 value is connected to the voltage input signal Vi, and this V2 value is nothing but the voltage drop across the resistor R1. Now finding the value of V2 and simply substitute in the value of Vd, we can find out the closed loop gain of non-inverting amplifier circuit for the practical op-amp. So from the circuit we can write the V1 value as Vi and V2 is nothing but the voltage drop across the resistor R1. Okay, now how to find the voltage drop across the resistor R1? So we know that from the voltage division rule, okay, so from the voltage division rule we can find the value of V2 as total voltage. Now here it is the point we have to find out V2. So V2 I can write it as total voltage into corresponding resistance. Now what is the corresponding resistance? R1 by total resistance, that is R1 plus Rf. Okay, so this is the value of V2. Now substitute this value of V2 in this Vd expression. We will get, so Vd is equal to Vi minus V0 into R1 by R1 plus Rf. So finally this is the value of Vd we have obtained till now. Okay, as we know that the output voltage for the non-inverting amplifier in the practical case op-amp V0, I can write as V0 as AOL into Vd. Now what is the value of Vd? Vd is Vi minus V0 into R1 by R1 plus Rf. Let us assume this constant factor R1 by R1 plus Rf with some unknown factor B. Okay, so let B is equal to R1 by R1 plus Rf. Therefore, I can write the V0 expression as AOL into Vi minus V0 into B. Okay. Now multiply. V0 is AOL into Vi minus AOL into V0 into B. Now take this V0 to the other side. We will get V0 plus V0 into AOL into B, which is equal to AOL into Vi. Now common V0 in this expression. We will get V0 as 1 plus AOL into B, which is equal to AOL into Vi. So finally, the output voltage expression V0 is AOL by 1 plus AOL into B into VI. So this is the output voltage expression for the non-inverting amplifier circuit in the practical case of op-amp. Now from this, we can know that the closed loop gain is nothing but the ratio of output voltage to the input voltage. So finally, the closed loop gain of a non-inverting amplifier circuit is AOL by 1 plus AOL into B. Okay, so this is final expression of closed loop gain of op-amp of non-inverting amplifier circuit in practical case. Thank you.